everyone. So we're finished doing things by hand, manually. In my AI class, we'll go a little bit further, but for the rest of this class, we're going to use a professional library to do the rest of our stuff with machine learning. In particular, we'll use a library called PyTorch, which is all the rage right now. You might say that PyTorch is very hot. Okay. So the reason we're going to use this is because the kinds of models we're going to use, the kinds of function spaces, are going to get more and more complicated. It'll be very difficult to code them by hand. And also there's just a lot of little hacks to make things go faster that Torch has done. And actually perhaps one of the biggest reasons is because PyTorch has some really good utilities for modeling big data sets. And since we're doing data-driven learning, that's going to be really important. So I actually want to talk about that first. So I want to talk about how PyTorch manages data and then collates it. So actually we're going to be using objects a little bit now. This is one time in the course. If you're a little bit rusty on object-oriented programming, that's okay. Just follow the patterns that you see here. But I first want to show you about something about classes in Python that's kind of interesting. So I don't know. I'll make a class maybe called evens. So I'll make a class that represents something about even numbers. And maybe I'll say, okay, I want maybe the first n even numbers. So I'll save that as an instance variable here. And that's good. Okay. So actually some people in 372 may not have seen Python classes before, and so I'll just show a quick example of how to construct this. So I might say, my evens object is equal to evens, and let's say maybe I want 100 of them. And so that's how I call the constructor on the evens class, passing along the value 100, and then I can, just like in Java or C++, I can use the dot notation to access instance variables, and everything is public. So anyway, that's how to access the n. Now one thing that you could do that's really interesting with classes in Python is you can actually overload, so think inheritance now, you can actually overload a couple operators that are usually used for collections. So one of them is this length operator. So let me show you what this does. So if I were to do this and I were to say print len of evens, well, that did the same thing I just did. But yeah, now when I say len of that object, it knows what to do. It says, okay, there's 100 things in here. Another thing I can do, which is even cooler, is I can define this get item thing. And so what I'll do here is I'll return 2 times I. Or maybe 2 times I, quantity I plus 1. So let me show you what that does. Now if I say something like print evens at index 0, that prints out 2. So what I've done here is I've overloaded actually the square bracket access. And so this is not an array, and it doesn't even store all of the 100 even numbers starting at 2. It doesn't even store them explicitly in memory. But when I go to access a particular example, it knows what to do. It says, okay, you're looking for the example at index I in that list. I'm going to construct it on the fly. I'm going to make it 2 times quantity I plus 1. So I could go along and say for I in range length of evens, print evens at index I. I'll put a little space in between each one, and there you have it. You've got the first 100 even numbers. So kind of a strange way of doing that, but this is a precursor to dealing with data in a more complicated way. So this is kind of a simple example, but in PyTorch we're going to use this to create a data set. Okay, so PyTorch has its own little class called a data set, and so what I'll do is I'll make a data set of points in the plane, because that was kind of the last example that we looked at, a bunch of points in the plane, somewhere in one class and somewhere in another class. And so I'll have a data set of those. I guess I'll call it blobs, because what I'm going to do is I'm going to make two blobs that are separated from each other. And so actually now I'm going to inherit from a class that comes along with PyTorch called dataset. And So let's go ahead and set that up. So I'll send a couple parameters along. I'll say, okay, there's so many maybe point samples that I want to have. They're going to be in a particular dimension. And maybe I'll also specify an offset between, like a margin between the two classes, ones that have a label 1 and ones that have a label 0. So I'll just write down what these are. So n samples, this is the number of data points in this data set. And then the dim, this is the dimension of each point. So we'll probably do a 2D example. And then offset, this is going to be a NumPy array with dim elements, and this is the amount to add to each point in class 1. So we're going to separate the points in class 1 by adding an offset to them. And so what I'll do for now is I'll just kind of remember this stuff. Actually, you know what? I think I'm going to specify the offset is just a floating point number. So I'll add that. I'll say the amount to add to each dimension of each point in class 1. So I'll just remember this stuff for now. So I'm going to remember these as instance variables. And I'll make the offset be actually an array of ones that all have the value offset. Okay. So nothing too exciting yet. I'm just saving off some stuff. But actually, right off the bat, I can define my length operator. So I'll return the number of samples. Okay, now let me define the get item. So this is interesting. In Torch, with a Torch Dataset class, the get item actually needs to return a tuple of x and y. So we're going to return the data. And we're also going to return its label. Okay, so here's what I'm going to do. First, I'm going to generate a random label. So I'll just make that mp.round, mp.random.rand. So rand, wow, this is more complicated than it has to be. I could probably say mp.random.randint2. Let me actually check that real quick. That should give me a number. Oops, I should define MP first. Okay, let me pour all this stuff. And then I'll start to test here. So this should give me a number between, that's either 0 or 1. That'll be my class label. Okay, actually it's an int though. I should be careful. I actually want this to be a float. Okay, fine. So I'll generate a random class label. I will also generate a random set of coordinates. Make sure that there's dim of them. And I'll say, okay, look, if the class label is 1, then I want to add that offset. Because I want there to be a separation between my two classes. Okay, now here's where the first time we're really going to depart from NumPy. So Torch has a lot of stuff just like NumPy, but we got to move our data over to Torch objects. So I'm going to say the following. I'm going to say, personally, I'm much more comfortable with NumPy, so I usually create stuff in NumPy first and copy it over to Torch. So I'm going to say torch.from NumPy. And I'm also going to make sure, this is going to look a little weird, but I'm going to make sure that when it gets copied over as a 32-bit float. That's because we're eventually going to do stuff, so Torch runs on the GPU. That's another reason we use it, so it's going to be able to do a lot of stuff in parallel for us. But the GPU can only store up to 4-byte floats. So we need to make sure that that's 32 bits. Just an annoying thing we got to do. And then I'll do the same thing for Y. I'll copy Y over to Torch. Even though Y is just a single value, I'm going to wrap it into an array. Make sure it's 32-bit float. So I guess I don't technically need to have that float wrapper there. I can just do this. And then I'm going to return the tuple XY. Okay. Very exciting. So let me just real quick, I'll make a data set of this type. So I'll say data equals blobs. I don't know, let's say that maybe n samples is, let's say we're going to have 1,000 of these. Actually, what's interesting is when we get the item, it may not actually be totally consistent. It's going to maybe give us a slightly different random item each time. And that's actually okay. When we do the machine learning, we're okay if it gives slightly random items. That's actually a good thing. that will help us with training. I'll explain that a little more later. But okay, but for now, so I'll do that. I'll say, you know, we'll use a dimension of 2 here, and maybe I'll say that the offset is 2 between these. Okay, so let's see what happens when I access data at index 0. It doesn't like that. Oh, I should have said offset equals 2. Okay, there we go. All right, so here's the first point. It's in class 0, and there's the 2 coordinates. Actually, if I keep accessing that, it'll change a little bit. I know that's a little weird. But again, that is completely okay. Let's do the following. What I'll do is I'll generate a bunch. So say for I in range length of data. So what I'll do is I'll get that stuff. I'll say, okay, x, y is equal to data at index I. And then I will scatter. So I know x is actually 2 dimensions here. And I can index torch arrays just like I index NumPy arrays. And so anyway, and I'll color it according to what class it's part of. That doesn't look like it worked quite right. So what happened here? Maybe it's because it's doing each one of these independently. So, okay, 1 second. Okay, I just had to give it a range for the colors. Anyway, so this is just showing you, okay, the things that are in class 1, they're showing up yellow here. They're separated by this offset of 2. So the mean of the yellow blob is coordinates 2, 2, and the mean of the blue blob is 0, 0. Okay, so that's what I did with my dataset object. And actually, maybe before we move forward, I'll give you just a quick exercise on this, just to make sure that it's clear how to create this sort of dataset object.